Welcome friends to the next session of Newton Raphson method. By this method we get closer approximation root of an equation. Let the equation be f of x equal to 0. Then we find approximate root by Newton Raphson method. Formula is xn plus 1 is equals to xn minus f of xn upon f dash of xn. Note, in the beginning we guess two numbers a and b such that f of a and f of b are of opposite sign. Then the first approximate root lies between a and b. If f dash of x is 0 or nearly 0, this method fails. Now in Newton-Raphson formula, so xn plus 1 is equals to xn minus f of xn upon f dash of xn. Now if we put n equal to 0, then we'll get first approximation x1 equal to x0 minus f of x0 upon f dash of x0. Now we have to decide what is the value of x0. x0 is either a or x0 equals to b. Consider the value of the function f of a or f of b which is nearer to 0. For example, consider for a polynomial we consider here f of 0 equals to 11, f of 1 is 6 and f of 2 is minus 3. That is, f of 1 is positive, f of 2 is negative, so root lies between 1 and 2. Here we assume x0 is 2 since f of 2 is minus 3 is nearer to 0 compared to f of 1, that is 6. By choosing x0 like this, it reduces number of approximations. Find a root of the equation x cube minus 5x plus 3 equal to 0 using Newton-Raphson method. Now first example we consider for algebraic equation. In the solution, let f of x equal to x cube minus 5x plus 3, then f dash of x equal to 3x square minus 5x. Now in this polynomial we substitute f of 0, 1, 2, 3 that real numbers. So f of 0 is positive, f of 1 is negative, so root lies between 0 and 1. Therefore, first approximation x1 equal to, we have formula. Now the value of x0 we assume here 1, as f of 1 is minus 1 is nearer to 0 compared to the value of f of 0 is 3. So x1 become 1 minus f of 1 upon f dash of 1. So we calculated by using calci this value and x1 become 0.5. Now second approximation to the root is x2 equal to x1 minus f of x1 upon f dash of x1. x1 we have first approximation 0.5, so we substituted all these values and we have x2 equal to 0.6471. Now third approximation by using NR method, x3 equal to x2 minus f of x2 upon f dash of x2. So x2 we have 0.6471, we substituted in this and we got here x3 equal to 0.6566. Next we find fourth approximation to the root is x4 equal to x3 minus f of x3 upon f dash of x3. So calculated all these values, we have 0.6566. Hence the root is 0.6566. Example 2. Using the Newton-Raphson method, evaluate to 3 decimal figures the root of the equation e raised to x equal to 3x. Now second example we consider for non-algebraic, that is transcendental equation which containing exponential function. Now this is our polynomial f of x e raised to x minus 3x, and we find here derivative f dash of x, that is e raised to x minus 3. So f of 0 here it is 1, f of 1 is minus 0.2817. So first value is positive, second negative, so we got here opposite sign and hence the interval is, or the root lies between 0 and 1. First approximation x1 formula by NR method we have. Now the value of x0 we assume here 1, as f of 1 is minus 0.2817 is nearer to 0 compared to the value of f of 0, which is equals to 1. So x1 become 1 minus f of 1 upon f dash of 1. So we calculated all this. So x1 become 1. Now in this, x0 and x1 become the same, so that consider the middle point of the interval, that is 0, 1. This is our interval, and middle point we consider 0.5. Now f of 0.5 we calculated, it is 0.149. Now we have three values. F of 0 is positive, f of 0.5 is positive, and f of 1 is negative. So a root lies between 0.5 and 1. Therefore, first approximation to the root is x1 equal to x0 minus f of x0 upon f dash of x0. This is the formula. X0 we assume here 0.5, as f of 0.5 is 0.1 and f of 1 is minus 0.2. So this value is nearer. So x0 we assume here 0.5. x1 become x1 equal to 0.5, f of 0.5 upon f dash of 0.5. Calculated this. So x1 we got here first approximation. Now second approximation to the root is x2 equal to, this is the formula. So in that we substituted x1 value 0.6103, calculated this. So we have 0.6190 as the second approximation. Now third approximation, x3 become, this is the formula. In that x2 value 0.6190, we substituted all this. So we got here x3 0.6191. So we corrected up to 3 decimal places, hence the root is 0.6191. Now third example, using the Newton Raphson method, evaluate to 3 decimal figures the root of the equation x minus cos of x. Again this is a transcendental equation, non-algebraic equation, which containing trigonometric function. Now f of x, this is our polynomial x minus cos of x. We taken here its derivative f dash of x 1 plus sin x. F of 0 is minus 1, f of 1 is 0.4597. So these are having opposite sign. So our interval is 0 and 1. Therefore the first approximation to the root is x1 equal to, this is the formula. Now the value of x0 we assume here 1, as f of 1 is 0.4 is nearer to 0 compared to the value of f of 0 is minus 1. So x1 become first approximation 1 minus f of 1 upon f dash of 1. Calculated this, it get 0.7504. Now the second approximation to the root is x2 equal to x1 minus f of x1 upon f dash of x1. We substituted x1 value here. So x2 become 0.7391. This value we use in the third approximation, x3 equal to x2 minus f of x2 upon f dash of x2. x2 value we substituted here, calculated by using calci, and this value become 0.7391. Hence the root is 0.7391 for the given polynomial. Now for more videos, subscribe this channel. Thank you one and all.